Hi, welcome back. Last time we tackled regarding one of the techniques, which is the integration by parts. So this time we will tackle another technique, which is called the integration by algebraic substitution. Algebraic substitution. Okay, so what is this algebraic substitution? It is a very useful techniques, especially when the integrand involves radicals. So usually it is used when the integrand involves radicals. Okay. We're in this, if we have integrand that is have radicals, then it makes it makes the integration more difficult, right? So we need to remove these radicals to for us to easily facilitate our integration. Okay, so this algebraic substitution here is used to transform in removing radicals so that we will be able to evaluate integrals. Okay, so this process is can be illustrated using, say, we have a sample here. So say we have x cubed d of x all over the square root of x squared minus 25. Okay, so as you can see here, the integrand involves radicals, and it makes the integration more difficult for us. So what we will do here is to change the variable, and we let some variable, say we have let u is equal to the radical part of the integrand. So we let say this whole square root here, x cubed minus 25, square root of x squared minus 25 rather, and then we will try to simplify this and to in order for us to completely replace all the variable x in terms of u. Okay, so say let us square this both sides. So if we will square this both sides, we have u squared is equal to the square root of the x squared minus 25 squared. It's just we will cancel out the square root sign, so yeah, x squared minus 25, right? And then from here you can see that algebraically we can now solve for the value of x squared. So we have x squared is equal to u squared plus 25, right? Okay, and then what else do we need? Say let's take the derivative of this. So we have 2u then du, right? And then the derivative of this one is 2x d of x, right? So as you can see here, you can now simplify this by dividing both sides by 2. We have u du and x d of x. Okay, so we manipulate this this radical in our denominator, and we come up with these values, right? Okay, so after that we can now change and substitute all our integrand in terms of u. So as you can see here, we have x cubed dx. So how can we change our x cubed dx in terms of the following information here at the box? Okay, so as you can see here, we have x squared and we have the x dx, wherein this x cubed here can be also written as x squared multiplied by x dx, right? Okay, we have x squared times x dx is x cubed dx all over, of course, the square root of x squared minus 25. Okay. Okay, from here you can now easily see that we can simply change all the variable x in terms of u. So our x squared here is just equal to u squared plus 25. So we have u squared plus 25, and then our x dx here is equal to u du. So instead of x dx, we will write u du. Okay, then all over this square root of x squared minus 25 here is just equal to our variable u. So okay, so we have completely changed all our variable x in terms of u. Now let's analyze once again if we can now use our formulas in order to integrate this integrand. Okay, so how can we simplify this? Say we will distribute this, multiply this one by one. Okay, so say we have u cube du all over u, this one, and then plus 25 tama ba? Yes, 25u du all over this term also. So as you can see here, we can now easily cancel out the u. So we have u squared du plus 25 integral of 25 du. Okay, so if we have something like this, then we can simply apply our basic formulas, right? But let's move back here. As you can see here, you can also try to cancel this out. U squared plus 25 u du all over u. It's just we can easily cancel this out. So we have u squared plus 25 du. Then integrate u squared du plus 25 du, right? Okay, we have do the same thing here. Okay, so it's up to you which solution you want. Okay, so let's say we are ended here and we need to integrate this one. So the integral of u squared is just u cubed all over 3 and then plus 25 du u, right? And then our plus c. Then right after here, you'll need to replace the value of ru and then need to move back the value of our x's. Okay, so bringing back the value of u, which is equal to u is equal to we have 1/3 times the u, what is u? Square root of x squared minus 5. Square root of x squared minus 25 raised to 3 plus 25 times square root of x squared minus 25, then plus c. Okay. Okay, so where are we? Okay, so this is now our final answer. But if you want to simplify this, you can also express this in terms of what do you call this, um, 1/3, then the square root is 1/2, right? Then 1/2 times raised to 3 is just also equal to x squared minus 25 raised to 3. Okay, then plus 25 squared x squared minus 25, then